So the next thing we need to do is go ahead and solve for the forces acting on our joints via our members, or the vector forces within the members themselves. And so to do that, I'm going to start with A. I'm going to start with joint A. And we'll draw a free body diagram for joint A first. So we'll say, okay, we got AD going down and to the left on joint A. We've also got AB pulling joint A to the right. And we've got a 300-pound force pulling or pushing joint A upwards. And then we've got a 60-pound force to the left, pulling joint A to the left. And we can actually redraw this even simpler without our diagonal forces and just have X and Y forces on it. And we can do that by looking at AD a certain way. And the way we'll look at it is we'll go ahead and redraw it. And we'll say, okay, well, vector AD is going down and to the left, therefore it has a downward component or a Y component. And we'll call that ADY, and it has an X component, or ADX. And so what I can actually do is replace my Y and X components with vector AD. So let's go ahead and redraw joint A. And instead of drawing AD down to the left, I'm going to draw a downward force, which will be ADY, or our Y component of AD. And instead of drawing AD down to the left again, well, to replace our X component, I'm just going to draw in an X component. So we say ADX. And these two forces combine to make vector AD, but they essentially do the same thing. And then we can redraw everything else. We'll still say AB is pulling joint A to the right. And we'll still say there's 300 pounds going upward. And we'll still say 60 is pulling, or I'm sorry, we should say joint A is being pulled to the left with 60 pounds of force. And I'm talking too fast for myself here. But from here, we can go ahead and start solving for our unknowns. So for example, we can say, well, the sum of all forces in the Y direction equals 0. And what forces do we know are going in the Y direction? Well, we know ADY is going in the Y direction on joint A. And we also know that 300 pounds, or Ray over here, is going in the Y direction as well. And those are the only two things that are acting on joint A in the Y direction. I don't need the pounds, actually, now that I think about it. So we just say ADY plus 300 equals 0. And then I'm going to look and I'm going to say, well, 300 is going up and ADY is going down. So I'm just going to set these equal to each other. I'm going to say ADY equals the downward force equals our upward force, which is 300. So, okay, we know ADY equals 300 pounds. Okay, so we can rewrite that here if we want to. We don't need ADY anymore. We know our Y component of vector AD is 300 pounds. And we can do the exact same thing with our three forces in the X direction. So we'll say, well, the sum of all forces in the X direction equals 0. And we just look at what forces are going in the X direction. Well, we know, well, AB is going in the X direction. And we know, let me get the right color here, we know ADX, or X component of vector AD, I should say, is going in the X direction. And we know 60 pounds is also going in the X direction, and that's going to the left. And for that matter, ADX is going to the left, and AB is going to the right. And if all these forces are adding up to 0, that means my rightward forces have to equal my leftward forces, so I can rewrite this to say vector AB equals, let me get the right color again, ADX, or our X component of vector AD, plus 60 pounds. In other words, these will add up to 60. You might say, well, we got to find ADX to solve for AB, but we kind of already have everything we need to solve for ADX. So what I'm going to do is I'm going to do my vector forces tip-to-tip method. I'm going to redraw ADX at the tip of ADY. And if you look, well, we already know the angle of this triangle we just created. We solved for it at the very beginning of this problem. It was 59 degrees. That hasn't stopped being 59 degrees just because now we're using forces, and before we were using distances. This directional force is going at 59 degrees. And so to solve for ADX, what we'll do is we'll say, okay, what do we know? We know the opposite to our angle, and we're looking for the adjacent. Well, that's tangent. So we'd say the tangent of our angle, 59 degrees, is equal to our opposite over our adjacent. Well, what's our opposite? I'm going to go ahead and make sure I pick the right color here. Our opposite is 300 pounds. And we're going to divide that by our adjacent, which is what we're looking for, which is just 80x. And so to solve for 80x, we can just do some simple algebra, although I like a simpler method. I like to just make this a proportion problem by putting this tangent of 59, which is just some number, over 1. And then I just cross multiply and divide. So I'll say 300 times 1 divided by the tangent of 59 equals 80x. So we go ahead and pull out our handy dandy calculator. Let me go ahead and show you what I mean. I'll say 300 times 1, which is essentially nothing, just 300. But on bottom, I'm going to put the tangent of 59. That'll give me 80x. So we'll say tangent of 59. And you could have just said 300 divided by the tangent of 59 if you recognized the pattern and figured out how this works. And what do we get for 80x? Well, we get 180, or about 180, I should say. And based on precision of our measurements beforehand, I'm going to go ahead and just say it's 180 pounds. And if I plug that in right here, we can say, well, an AB is going to be 180 plus 60. Well, I don't need a calculator for that. We just say AB 180 plus 60 is 240 pounds. And that's one of our vector forces. Right here, that's one of our members' forces, which is AB. And then we need to solve for AD as well. But if you look again, we have everything we need to solve for AD. So to solve for AD, there are several ways to solve for it. Let's see, we know the opposite, and we're looking for the hypotenuse. That sounds like sine to me. So the sine of our angle, which is still 59 degrees, well, that's going to equal our opposite, which is still 300 pounds, divided by our hypotenuse, which is vector AD. And, well, what do we get for AD? We got to plug it into our calculator. It's going to work the same way. I'm going to put this over 1, and I'm going to cross multiply and divide. We get 1 times 300 divided by the sine of 59. So I'll just say, this time I don't need to plug it all in. I know 300 times 1 is 300. I would say 300 divided by the sine of 59. And what do we get for AD? We get 349.99. I'm just going to round that up to, I'm going to make sure I get the right color here. I'm going to round that up to, what was it again? It was 350. 350 pounds. And I just want to make sure I wrote down the right number. That's all the member forces that are acting on joint A solved for.